So thanks a lot. Today we're going to talk about Duke Energy's experience with the remote visual guidance, as well as a few other cases, things that we have done during the pilot, as lessons learned as we move to the enterprise solution. My name is Vukojevic. I work for Duke Energy, Emerging Technologies Office. My background is in power systems, so that's why I have here my coworker, Rodney James. So we're going to try to go through this together. So essentially, the agenda for today, really simple. We plan the project, we execute the project, we do lessons learned, and we try to see if we can transfer this over to the business and how do we move with the enterprise solution. And for the end, there's some next frontier, something that we're trying to work on. So it's just the beginning of that project. So as I said, we tried to do this started this in 2014, and I think we have tried just about every single piece of glasses that you have. This is just 7 of those that we've tried. There are probably 2 or 3 that we have not tried. Some of those companies are not in the business today, right? So depending on use case that we try, different users like different hardware. So what works for the person in the warehouse does not work for the person on the top of a turbine. Each one of these, they have their pros and cons. We're just going to talk about it later on. And then for software, Rodney.
Hi, like I said, my name is Rodney James, and one of the things that we've, not only with the hardware, is also the back-end software. These are a couple of different products that we've worked with, Ether Air Suite and HPE My Room. We still have another one that we have to work, Scope AR, to work and set up and get working in our space. But again, they offer a couple of different platforms, again, connecting the glasses to these back-end software suites.
Yeah, and just to let you know, when we do the projects in emerging technologies, we actually try to find a vendor that we work with. This is just to prove that the technology works. After the technology is transferred, then there's another group that actually goes to the market and evaluates the preferred solution.
So again, one of the things that we try and do is we remain pretty much software and hardware agnostic. Again, one of the things, as you see, that you'll not only have the hardware, you have the back-end software, but then how do you connect them on a communications layer? Typically, you'll have a couple of different flavors of communications, especially for your outdoor technician. We've looked at different flavors of the Verizon Jetpack, either with a Samsung or their own Qualcomm suite. And then there's the AT&T Unite. We've not been able to test that one yet, but we're looking to get our hands on that one pretty soon. And then also, like we have your iPhone hotspot or tethering to a phone.
Okay, so we have done several use cases when it comes to the remote assistance. These are some of the use cases that we have originally tried and the ones that we have kind of recently done. In 2014, it was just live video and audio with GPS location. That's what was available back then, right? And then in 2015 and 2016, well, some more advances were made on the software side, so you could do some annotation, you could attach things so that the person in the field can see some stuff, etc. In 2016, we have also tried something for our power quality group, live video and audio with workflow assistance. And then most recently, we have done live video and audio with the GIS. GIS is our system, our database where we have all of the assets in our systems, and we try to use some beacons for the integration, as well as the OEM procedure implementation. So when you work for utility, these are just some of the internal stakeholders. And just remember, for every generation, transmission and distribution, you got maintenance, you got construction, and then you got engineering. So as you can see, there are probably 20-something departments that you can pick from to work with. So that's why some of the use cases that we have, they're just not live video and audio, right? We have done also warehouse picking, we have done warehouse counting, we have done storm restoration app, we have done operations and maintenance procedure. So there's a lot of places where we can actually implement this technology, right? So here's just a basic one. This is from 2015. This is pretty much me standing in front of a device. And this is the person in the back office that he's looking at the stuff that I'm seeing, right? Pretty simple. Now, this is something that we have tried later on. How many people here actually work in an environment where you actually have to have some sort of a workflow, as well as also where you actually, because of the compliance, you have to record that workflow? Okay, so there's some, right? So we tried this workflow. It works fine. We did not get to the point where you can actually just open up the app, go through the workflow, and the app can actually record every single step where you went to, taking a picture, etc. This is something that is probably something that we're going to try to do next when we get into the enterprise side, but it's much more effective than going through the set of papers of trying to write yes, no, etc., right? And then how do we execute pilots, right? So doing pilot project and doing the same objective within the enterprise is a little bit different, right? So here's the existing infrastructure, right? Okay, so you have Firewall. Firewall on the right side, that is Duke Energy infrastructure. What you see over here on the left side is how we do things today, right? We have talked about this. You have that MiFi. It goes through the cellular network, software head and solution and back. What happens if we try to go through the firewall? It does not work, right? So when we start the pilot project, everything is off the network. We're necessarily not trying to show integration with the existing systems. We're trying to show that the information to the end user can be shown in a different way, and is there a benefit to it, right? So some of the lessons learned. Because we have tried so many use cases, what are the chances that everybody can agree on one set of hardware, right? 0, right? Everybody likes something different. So there is no silver bullet for this solution. We have probably had like 4 or 5 different preferred hardware cases, right? Second of all, everybody's familiar, field of vision. Majority of these things right now, 20, 30 degrees, as opposed to human, that's about 190 and 120, right? So for some use cases, certain hardware solutions have a small screen. In all of our use cases, 720p cameras did not fare as favorable as 1080p, especially in live video and audio case. Sometimes you do have to understand how does your software work, because you want to make sure that your software can actually pull 1080, right? Hardware audio, we also had some challenges depending on which one we use. Now this is exemplified, especially if you're working in the generation plant, because if you have ever been in a generation plant, you cannot hear a person standing 2 feet next to you. And there's no really chance to hear somebody unless you have good audio, right? As you know, we work for the utility, so right now, we need certification of these safety glasses, and a lot of these are not safety glasses. So one challenge was, you know, if I have to use my hand to keep pressing through the buttons, is not as fluent as if you just talk to it, right? So voice recognition is much more preferred compared to the button pressing. Battery life, we know that battery life only lasts so much, right? But there are some add-ons today. In electric utility, at least with us, we must disable the Bluetooth. That thing cannot be working. And also, what we have recognized during some of these pilots is that we really need some extra sensors, and we need higher computing power, because if you want to do live video and audio, a lot of times you have jittery stuff, it's frozen, it's delayed, and more about the communication and software challenges from Rodney.
So then also one of the things that we noticed in for the communications part is that communications wasn't seamlessly running at all the time. So if we were doing outdoor tests using a jetpack, we found that sometimes you would have your glasses would intermittently connect with your backend software. So that might be something where even though we saw 4 bars, 5 bars from our jetpack, we still did not have great communications, but great communications back to the head-end software. We're still trying to see what that looks like. So sometimes slow communications cause back office users to see frozen or jittery screen. Many times working with Alex, it was a lot of, can you hear me now? Shake your head if you can hear me, don't move, things like that. So that's, you know, so one of the things that we'll have to always take care of is that we have seamless communications. Your best uploads and download speeds were pretty low. Again, that goes back to jittery or compressed video and or audio. And then also there's fragmentation between your hardware and software systems. So again, you have differing Android flavors within your hardware, within your glasses hardware, different network capabilities within your transportation layer, and then also different capabilities in your software and your head-end software layer. And then also, we didn't really test standards because there's not a standard for this seamless communication that you want to be seamless from beginning to end. And then also too, how do we incorporate cybersecurity strategy? Again, when Alex demonstrated that a lot of this was done off the network, as we look at these devices to go on the network, what does that look like? Duke Energy employs AirWatch to authenticate devices on the network. How does that work well or not well with our strategy and implementation? The other thing that we saw is that with GPS, the GPS that's either in the glasses or that's usually in the glasses is not survey grade. So the information, we have our asset accounting within Maximo. That's the database system that we use for stuff within Duke Energy. Maximo has a very detailed location of where things are when your glasses may not. So you may be looking for a pole that's actually 10, 50 feet away. Especially in a storm issue where a pole's been brought down, you're trying to figure out if that's pole X or pole Y. That leeway in GPS communication within the glasses could be a problem. So that can be where the information between your GIS system that we have versus what's the glasses reporting to us can be a problem. We will try and test the bad ELF GPS, which will give you more pinpoint GPS location into our data systems to see if we can shore that up.
Yeah, so where we are right now, so we have tested these different use cases. In addition to this, like I said, we tested different ones, and we've had some decent success. Now, I wish I can tell you that we had success in implementing this full-scale implementation, right? We had a lot of success trying to find all the challenges associated with it, but what we're going to try to do is just try to summarize a few of those so that you can see. If you ever work with utility, you have to understand it requires a lot of patience because there are many layers to the utility that you deal with, right? So when you see everything in pilot project, what I have is on the left side, right? So all the infrastructure that you have hardware, you have software, and you have communication that exists, right? As opposed to enterprise solution, where you actually have to build some of these things, right? Then on the software solution side, during the pilot, it's always cloud solution, right? But when you do the full-scale solution, it has to be on the premise. And for those who have worked with utilities, you know we don't prefer or we don't do cloud solutions. So everything with us is either virtual machine or a server, right? In pilot project, we don't integrate with any internal systems. We just take some kind of database that represents that system, whereas in the enterprise solution, you would have to do that, right? During the pilot, we don't follow standards. We follow all the safety standards and everything else, but when it comes to enterprise solution, we will have to follow all of the standards before something becomes accepted as a solution, right? So we didn't have any concerns with respect to the comms and the bandwidth, but for the enterprise solution, somebody will have to go over there and calculate that because typically we do not allow video internally, right? Like I said, we do not do use cases in terms of financial side. We don't do ROI. So before we implement this, there's a business person with respect to the department that will have to do that. And security requirements, when we do the pilot, we really don't have any because we don't tie to anything. We don't have any, proprietary information, but enterprise solution will require a lot of those. And Rodney.
So then one of the things we'll see then for moving from the pilot phase to the enterprise solution, the main thing will be building an IT infrastructure, whether that be using your Jetpack as your transport layer or tethering to the phone. That'll be very important to whatever solution that we come up with. And then also too, how do we do this build versus building something completely new, but then also interfacing with our older legacy system, and how do we get those two to combine? And then also too, one of the things that we've seen is that many companies do not have the capability to support AR and VR at the same time. So one of the things that we'll have to see for us, specifically with Duke, like I said before, is that any hardware solution that we do implement we'll have to also implement with our AirWatch, which is how we authenticate Android devices on our network, inside the Duke network. And then integrating with the existing internal systems is always going to be the first time we've ever done this. And so there's going to be quite a bit of hand-holding to get that in line. Previous integrations with different systems, our OMS systems and our GIS systems, doesn't mean that integration on the same system will work with the same utility. So because we do it with this system and how we've made it work, doesn't necessarily mean it'll be the same for you. And then every integration will have to have some kind of work to convert things from one platform to the other. That's just going to be the hand-holding that's going to be necessary. And then also high bandwidth or network connectivity may not always be available for that device. If you're thinking of a wind generation technical person or a meter operator out in the field, there's going to have to be some type of different connectivity. One of the things that we're looking at or thinking about is vehicle WAN. So what if your trucks had a version or implemented the corporate network and had a stronger Wi-Fi signal from the truck? We're looking at that. That's another thing, outgrowth of the work that we've done. And then also to the software architecture of the whole solution. So that's going to be something where we look at a different, or we look at a back-end software that pretty much comprises all of everything that we're trying to put together.
Yeah, and just as an example, if you do O&M procedure as a part of the pilot, you know, it might have 10 steps to go there, cut and paste, it works fine. Every wind turbine has about 800-page manual. You have 25 different turbines. So give or take, you have about 20,000 pages of procedures. You can't go over there and start cutting and pasting every single one of them, right? So that solution for the enterprise is totally different than for the use case, right? And just to let you know, IT Ideation Labs, so these are the people, we have about 30 people that actually do nothing but write apps inside. That's for internal mobility. They connect to different systems, et cetera, right? They will be part of this team. So actually every app that we do with somebody outside, we can actually do internally. However, they're experts in tying to different internal systems, right? So this is something that I presented last year, and right now I got something to show you, right? So we're always concerned, what about if we just have, smart glasses? But every conference you went to, what is everybody talking about? Artificial intelligence, et cetera. So this is from the last time that I presented. So what if you have a server with artificial intelligence capabilities that can tie to everything? So rather than using the same procedure where you actually have to go and get the data from 5 or 6 different databases, et cetera, for the inspection, what if you have this? So that's in kind of how it works in PowerPoint, right? So here's how it works with the artificial intelligence implemented on the procedure that we typically use for substation transform. Can you play the video?
I'm about to start doing the transformer inspection. What's my first step?
The first step is to do the transformer visual inspection. First, you would need to check the bushings for contamination, oil leaks, oil level, general transformer condition.
What's my second step?
Check the transformer for oil leaks.
The oil level gauge is showing low oil level. When did the alarm come in?
The alarm became active on August 1st, 2017 at 1,100 hours.
Did the transformer have any top oil temperature alarm or hotspot temperature alarm during the same day?
No, it did not.
What was the maximum loading during the same day?
The maximum loading on that day was 25.5 kVA or 68.92%.
What is the third step?
Check the panes, any potential bushing gaps, and lightning arresters.
Now here's the variation. Here's the benefit to artificial intelligence.
What was the maximum loading during the same day?
The maximum loading on that day was 25.5 kVA or 68.92%.
What was the max loading on that day?
The maximum loading on that day was 25.5 kVA or 68.92%.
Is there an alarm on the DGA monitor?
No, it did not.
Does the DGA monitor have an alarm?
No, it did not.
Do I need to check anything else on the cooling system?
You need to check the loss of AC alarm by opening the circuit breaker to the control circuit within the transformer. This should send the loss of AC alarm.
Okay, you can stop, right?
Is there anything on the cooling system that could cause this?
So what we were trying to do here, we were trying to see pretty much similar stuff that you can put on the smart glasses. What happens if you tie it back to the system, right? So now we just need to somehow combine these two together. Now we have done this with the Spark Ignition. We have worked with them in the past couple of months. They have built this for us, and it's a three-step process. You don't get to this, right off the bat. But what we also want to do right now, because we have a lot of data, you can actually put analytics. So that's probably going to be our next step. Put the analytics on top of this artificial intelligence machine, so that actually you can get a whole lot more rather than just, what is the maximum temperature. You can ask about failure modes, etc. when you put a lot of analytics on top of this. So pretty much that's our presentation for today. I think we have about a minute and 30 seconds for any questions. Yeah.
How did you manage to lock down your hotspot, your Wi-Fi, to keep people from doing things like streaming Netflix?
Yeah, so what you would for in the pilots that we were working with, we pretty much had your open access your hotspots. Now they were tied with your standard WPA2 encryption, so they would have that security in place with the glasses. The glasses, again, since they're an Android device, they already remembered that connection to the hotspot. If you didn't know that, if you didn't know the access to a particular hotspot, then you couldn't get on. Same thing is if the glasses were connecting in an access point infrastructure, let's say in your business, again, you would have that you would go with whatever security models within the company.
No, I understand how you can secure it between the glasses and the hotspot. I'm more curious about how you kept the user who had that hotspot assigned to them. How did you keep them from doing things like using Netflix?
Well, it was our hotspot, so no, we never like gave it out. Either the hotspot was always in our control, whether it be with Alex or myself.
So if you were going to do a deployment, how would you do that?
It would be totally different because number one, you have to put it on the AirWatch, right? Number two,
Hotspots will go on AirWatch.
so this is how it works right now, right? I don't know if we're going to use. We were just trying to see what works. Probably. So we would most likely use those jetpacks that you see. That's issued by the company. So it is a cell network, but it is our network as part of the bigger network. We were just trying to see what works. Sometimes, I'll be honest with you, communications is literally do or die, so to speak. So this thing has dropped down so many times, and actually the best performance we had with 2 bars with the hotspot compared to 5 bars with the MiFi or something like that, right? Now, full-scale implementation will have architecture designed by the IT architecture team, professionals, because I'm not one, to be honest with you, and that's what their job is. So we have a IT and security part that will be part of the overall solution. So they're actually we wrote the RFP for the software solution, but they're actually adding their piece to it so that we can get that stuff.
Mike Lucci with Pepsi. You had mentioned that you have a plant for producing generators. Did you do anything different there for connectivity?
So we did 2 things, right? For the in generating plants, our pilot was actually on the outside. We did have a request to come inside from a different plant, and all of that network is Wi-Fi. We did not go there. We haven't tried that yet. It's a nuclear plant, so you can't really do everything that you can do in the other plane. So we don't know what that solution would be, even if we try as part of the pilot. But on the generation plant, what we have tried was outside inspection.
If you have a minute, I have a suggestion for you for a solution for that after your talk.
Sure. last. Here.
In terms of your, sorry, one last question. In terms of your use cases, which ones did you find from the pilot project are the most promising ones for rollout to the enterprise? Do you have a priority?
What we are trying to do right now is the most promising department within Duke Energy when it comes to accepting some of these new and cool technology from us is actually Duke Energy Renewables. So if it all goes well, most likely the first implementation is going to be the operation and maintenance procedure for the wind turbines, because carrying 800-page manual with you up to the top, and then you have to carry about 25 of those. You know, sometimes you can also have them on your iPad, et cetera, but it seems like if they can save a lot of money, that would be probably the first use case. Thank you very much.
Thank you. Appreciate it. Yeah, thank you. Appreciate it.